Okay, this is the P4 paper from October 2020. This is question number 1 we're going to be looking at, and it's a proof question, in particular, a proof by contradiction. So let's have a look at it. It says, given that n is an integer, use algebra to prove by contradiction. If n cubed is even, then n is even. Well, this part here is going to allow me to make an assumption, and the way that we do proof by contradiction, I'm going to assume the opposite, go through some mathematical processes and come up with something that's not true, and so then I can say my assumption is wrong, and so this is right. So let's actually explain it in a bit more detail with this actual one. It says, if n cubed is even, then n is even. Well, I'm going to assume the opposite. I'm going to assume that n cubed is even when n is odd. So I've assumed the opposite of what I'm trying to prove. Now let's go through and come to some sort of problem in that statement. So if n is odd, then I'm going to say n can be written down as 2p plus 1. That's how we would consider an odd number. So then n cubed is going to work out to be 2p plus 1 cubed. Now you might want to expand this using a binomial expansion or anything else like that. As long as you take a little bit of time over this, what I'm actually going to do is just say 2p plus 1 squared times 2p plus 1. 2p plus 1 squared is 4p squared plus 4p plus 1 multiplied by 2p plus 1. Perfectly honest with you, I don't know how many steps of this we would need to do. I'm going to now put what n cubed is. 8p cubed plus 12p squared plus 6p plus 1. I think that's enough steps of working out to show that I've worked out p or n cubed, 2p plus 1 cubed. And now the whole idea is I want this to be even, and that isn't even. Now you can't just say it's not even. What you need to do is, if I look at this part, all of that can factorise and 2 can come out. So 2 lots of 4p cubed plus 6p squared plus 3p plus 1. And why did I do that? Because I can now say this is 2 lots of something plus 1, and that's definitely odd. So that is odd. I'll say which is odd. I think you could get away with just leaving it like that, which is odd. If it's odd, then my original assumption is now false, okay, because I wanted that to be even. Therefore, my assumption, I always finish off with the same 2 sentences, really. Therefore, my assumption is false. My assumption did not work, but I use that language. My assumption is false. Therefore, and whatever we were trying to prove in the first instance, in this case, the bit that's underlined there, therefore, if n cubed is even, then n is even. Okay, so that's a relatively straightforward, quite short proof by contradiction question. Hopefully that will make sense to you.